How you go?
Yeah, it's fine, but I can move it later down for the robot, I guess.
Right, so welcome everyone to the final session for the day, which we see the return of Anders, let's see, last name, Arnholm, Anders Arnholm, who will talk to us more about Arduino and designing open source robots. So, we have
some. Yeah, we have some. So, I will talk a little about designing open source hardware, an open source robot, open hardware. There's a little different code when we talk about open source and hardware, because hardware is usually open source. Few small things about myself. I had this morning. Started at Universitet in programming, then got to work at Hackio, mostly sitting out at Ericsson, different sites, doing embedded programming there. Then I got employed by Mikael as a Linux expert because someone thought I know something about Linux. Actually, I know more about OpenBSD, but Linux, OpenBSD, same for some people. In other places, it's totally different. But for them, Linux, OpenBSD was the same thing. And then Delphi is an American company that owns Intel, and there are maybe 3 more of them now. That was very short. Let's go over to what is a robot. There are many definitions of what a robot is. But I think these 3 parts, most people are agreeing on. It's a mechanical or virtual agent. So a robot doesn't have to be anything physical. It could also be something that reads out web pages or something like that. That's also a robot. So it's some kind of agent working on its own. And they can be autonomous or semi-autonomous. Autonomous, they are doing all the decisions themselves. Semi-autonomous, you are telling them go there and do that, something like that. And they can move around, operate mechanical limb, sense, manipulate something in the environment, mostly. That's a little way for the virtual thing, what is environment. But that's the basic idea. And I wanted to learn more about hardware. That's why I started this project. Hardware is sometimes needed for software. So I decided to make my first robot. I wanted to make it very simple. My goals was I wanted it to run autonomously, so I don't, no lines, no radio control, anything. It should work by itself, because I thought that was a good idea. The easy design goal is it should run around and don't fall off the table. That's all the goals for what it was supposed to do. And it was to build using open hardware as much as possible. I'm not sure all the semiconductors actually are open hardware, but there is a limitation. Where is it part? And yeah. If you go all the way, it's starting to get fuzzy. So a robot has several different parts in it. There's some kind of engine, some kind of power, some kind of brains, and needs some kind of sensor like eyes or something like that. So that's the main part of it. And for my body of the robot, I made it very simple. Just a plastic sheet found in a drawer. That's the easy part. And then I had found some other mechanical parts here, and I had another little plastic part that I cut through to put the power switch in, and I don't think, it depends on what you define as a body, but I also got these wheel sets on ready, with wheels and engines fitting, and I have some place to mount the part of the body is somewhere you need to mount it, so it's actually don't fall apart. That was, make it as simple as possible. That's all of it. Then, for sensors, I took the most easy way. I think the most easy way. I have 2 photoresistors that are in the front here. And they are connected to the Arduino like this. The resistance of the photoresistor changes with the light, and I have another resistor here, so the analog input ports. So the current over the input port is varying depending on the photoresistor. So I can read out how light it is on that sensor. And I made two of them, put them apart out using just the cables. And that's a very simple way to see if the light changes. And my idea is that when you go over the edge here, the light actually changes. That's very simple and not always true. But it works most in the case. If the light in the room is quite okay, it works. If the table is too much different in colors, it stops earlier. If there is a lamp on the table, it also will change earlier. So it's a very simple idea, but it mostly works. And I think that is a big downside of this robot at the moment, is that the sensors are actually too simple. This way of measuring if the table length is a little bit too simple. But most of the time it works. Then comes the hard part. And actually, maybe I overworked this part, because this is a power regulator part of the robot. And I had always in my mind that I should be making a bigger robot someday. So I started to investigate what I was needing from the power regulator. And the Arduino is running on 9-volt battery power. And the engines are running on 6 volts battery power. So I needed 2 power sources. Or the recommended when you use it's good to use not the same power source, because if you start the engines, the logic could fail if you are using the same power source. Probably it would have worked with this small robot, because the engines are so small anyhow. So probably could have used one power source. But when you're learning, you maybe do something that gives you more for the future. So let's look a little bit more into this one. So it's 2 batteries. This is for the engine part. There I have a fuse as well, to make sure I don't draw too much energy from the batteries. And here I connect the switch. That's actually a dual switch here in the front. So this one is 2 switches in one. And they are connected into here by cables, so it could be sitting on the body easy. That's why you see them as pins out here on the actual power board. And I have this power regulator circuit that takes in somewhere between 5 and 35 volts, and the output is always 6 volts. And it's recommended that you are actually from 7 volt the input of it, so it actually gets to 6 guaranteed. So somewhere between, I think 7 and 20 is the recommended area for long time use. And into that I have this pack of 6 rechargeable batteries, so I have 9 volt in there. Also there I made a little light and LED here with the resistance, so I can see when I turn the power on. Because it's a good idea to know when you start it. I also see 2 capacitors between that. A really big one, which was the biggest one I can find lying around unused, and a small one. This is to, when you start or stop the engines, they will draw more or less power. And to even out this power, you have the capacitor filtering out the spikes in the energy. And on the Arduino part, it's very easy. I just feed in 9 volt, and the Arduino have all of this copied inside it. So it already have a power regulator that actually goes down to 3 volt, 3.3 and 1.5, I think. There is a lot of this stuff on the actual Arduino. So that's one reason to use that hardware. It's very easy. Power it. And for engines, there are 2 standard brushless DC engines, one for each wheel. And to make them run forward and backward, you have something called a Haybridge connector. And that is if you have actually 4 switches for each engine. And if you connect switches this way, power will go one way. And if you change, power will go the other way around. This is a standard way to connect the DC engine. And also you have this, 2 of them in one chip. So you can control 2 engines from only one chip. And you have one more connector that actually is sitting here to enable and disable all of it at the same time. And it's also so that these 2 are connected to one pin, and this transistor doing the switching, so you get 3 pins to steer each engine. Enable, input 1, input 2. And that will, you set that will go either forward, backward, or not at all. So that's the idea. Also, when you run a DC engine, you always try to run it using the optimal voltage. And for these engines, that is 6 volts. And you regulate the speed of the engine by turning it on and off quick, using a PWM signal. Do you know what the PWM signal is?
Yes. No.
No? PWM signal is that you turn something on for a part of the time and off shorter or longer time. So you either have it on or off depending on the time, instead of regulating. So and when you do it quick, it acts like it has in the middle in between on all the time and off all the time. So that's how you control the engines. And for the cranks, I went for the Arduino board. And the reason I did this is a quite easy platform for hardware beginners. Like me. I'm a software guy. This is a hardware problem. The input and output from the Arduino is well protected compared to a Raspberry Pi. Raspberry Pi is much more powerful, but if you do anything wrong on the pins there, you will burn it. The other thing is this one is a 5 volt out system, and most of these easy electronics is actually 5 volt. 3.3 volts are much more harder to actually do. You do have to do boards and actually do pitmonterad kretsar. Vad heter det?
Surface mount.
Surface mounted, or much more, and that's much harder for a beginner to actually work with. So it fits well for a beginner to start here. The Arduino is also very low powered. I heard numbers that they can run an Arduino for a year from a 9 volt battery. They had to change something on the software, mainly the sleep function. Because the sleep function in the standard does actually run the CPU for that time. They have to change that so it actually does better sleeping. So they can run it 1 year from a small battery. And it's also quite easy to make these shields that you put on to the Arduino with your own electronics. There are many standard ways. There are many people that actually do these things over it. Now we're into my software. I have divided up the software in some parts. I have an engine controller, driver, part of the software that controls 2 engines at the moment. I have a part of the software that controls light sensors. I have, to make the programming much easier, I have a state machine that keeps track of what to do at different moments. One state is driving forward, waiting for the light sensors to change on that one. And I have a little timer class as well, because the Arduino doesn't have any easy way to do timing stuff. You can count it yourself. But I want to, I'm measuring the time run forward and I set the timer on it. I want it to go backwards and also have a state. I can show the states I have. First state I have is a calibrate state, where it actually reads the light sensor for a few seconds to make sure how light is going now. But it's fluctuating a bit, so it's good to get the start value. Then it has a little wait state before it starts running forward. And that runs until it gets a callback from the light sensor software telling it now the light has changed so much we should do something. And it waits a little bit more when it actually turns off the engines, because the engines, when you turn off the power, they don't stop at one. It takes a little time before they stop, so I have a little bit more there. And I have a reverse state, and it runs backwards the same time as it runs forward. And it waits a little bit more, and it does it. Then it goes into rotate state, where it rotates one engine going forward and backwards for a little time. And then the wait state again, and it goes back and forward, so it doesn't look exactly like this. Any questions on that part? No?
Why did you have the weight between the different sets?
Because when you turn off the power to an engine, it's still running.
Okay. You
Because-
wanted it to stop completely?
Yeah.
I see.
and it's a quite short
Oh.
wait, but it's a short wait.
Yeah.
So actually the physical movement is stopping.
I see.
Works much better. This is the tools I'm using for this. First of all, I have used a tool called Fritzing. That's a German program for making boards, making the layout of the electronics. You can also, with it, order boards from them. And that's how they make the money for the project. And they are collecting a lot of orders, going to a producer somewhere, and they get them back later. So they're quite cheap. I think they take 10 euros for a standard Arduino. So that's quite cheap to make it. I think if you want to order it somewhere in Sweden, I think they take 3,000 for the first start. But then they are working quicker, and you get the. This is off labeling somewhere. Of course, I use the Arduino IDE. Most for the compiler part. I'm actually not using the IDE as such, more to learn how the hardware actually works. In some cases I have been using short test. I'm writing all my software test driven using the Google test framework that I was talking about earlier here. Also the Google mock from there. That is simulating all of the parts of the software before it's actually running. And I use CMake to put together the build system. The actual code is free on GitHub for all this, including all my drawings and everything. I hope it should be possible to make it for someone else.
Just a question, were you using some STL library as well? C++?
Yes,
I read on the-
I've got that. Yeah, I'm using an STL library for the Arduino as well. Africa, really. It's quite a simple STL library. Actually, I don't think I use it anymore because it was for debug printing and I didn't get it working on both magnets at the same time. So I think I removed the use of it.
Okay, so you are writing code in the Arduino language, so to speak. I'm not sure what language it is.
The Arduino language is C++,
Okay, it is. Okay.
except they are hiding the first include arduino.h. So it's C++, and they try to say that it's some other language, but it is C++, and they're using GCC as compiler for all of it.
Okay.
It's C++ compiling it. They do a pre-processing where they put in the one line in the beginning, include arduino.h.
So how do you practically, when you run the compiler with CMake, and then how do you get it onto the Arduino?
I do make upload. Oh, I should have it there. I'm also using CMake toolchain thing for Arduino that has this upload command for
Okay.
uploading. So that's another library I have put.
So it's basically a command line thingy to
Yeah.
upload.
And most of the time I'm using GNU make for actually building. So it's GNU make command, make upload, and it uploads to the connected Arduino. And see if I can get this one to switch. This is some attributions for the images I have stolen. Presentation. So I should see if we can show it up here somewhere. Not. But the last time I should change. Not now. So. Actually, I have a little back script that I use as a make command. Runs all the test tests, and makes a target. So this also shows the tests there fail for some reason. It doesn't go valid for the target. All of my tests are running on the normal DCC on the target, where I simulate all of the environment in the. And so I can test everything at first, and then it makes everything for the target. And to actually make it upload, I need the cable. Everyone notice, there are 3 ways from the USB cable. Wrong, wrong, and right. Always. Actually start running on the, using the free this, so we get it updated. It's a quite nice environment to work in. You can actually look at the software. This is my main program. We can actually look at the first main program. This is the main program that you get from the Arduino environment. This is what the difference is from C++. A very simple program. If you have any USB device, it actually sets it up and then calls your setup function. First when you have an individual environment, and it does a simple loop calling the loop function every time it runs through the loop. And it also has an extra call here to check the serial port between each time we leave the loop. And that's all it does. It's a very, very simple loop function to get. So this is the idea of my program. And here is what you don't get from the Arduino environment. And the Arduino environment adds this single line on top. That's all it does to the C++ code. And then I clear a lot of states. I have a callback for my sensor functions. And I have calibrate coming here, state. And here I can also change the time it takes for how long it will run this calibration for. So if I wanted to calibrate a little more, 2 seconds. Great. can have all of it working inside my thing. Now we should calibrate the sensor for 2 seconds and then hopefully not running off the table. I think I have a sensor a little bit higher from the table now. That's why it's sensing so much of the There are a few things more I have to do with this robot. You can see here when it runs long distance that it actually is not running straight. That is because actually putting the same voltage on the engines doesn't make it run straight. So I have sensors actually, encoders on the wheels that I'm not reading now. And they have to be put up and read to actually see what the speed I actually get from the engines. And I haven't done that yet because I was using this very simple prototype board where I put everything in. And on the Arduino here, that one is not aligned with the same distance. And so I can't use any of these digital I/O pins. I can only use the 8 of them. And I need 8 to run the engines. I don't need 6 to run the engines, and the first 2 are the TX and RX connected. I could read, but it still doesn't work enough to get these 4 encoders down here, so I had to make a real board to actually be able to read them. So that is my next step, taking the Arduino prototype board and moving everything into that one. And the first part of that is what I've started with. I'm taking out the power regulator from here and putting it on a separate board, so I can reuse that much more. That's a step for the future on this little robot. It was about what I had planned to say, and we are about 50 minutes for questions.
That's couldn't have said it myself, but I'm going to say it anyway. Are there any questions? Please take this opportunity.
Yeah, the various components that was not from the Arduino package, so to speak, where did you get those? Just Alpha or?
For the engines and the Arduino, I went to a shop called Lavicell.se. I think they are located in Skåne or Halland.
Lavicell.
Lavicell. Lavicell. They are one of the...
I think if you Google Arduino and Sweden, I think...
Or Google Raspberry Pi in Sweden, and I think they also show up.
Yeah.
Okay, cool.
Arduino,
Do you live in Gothenburg?
Yes.
Yes. There is a very nice... Okay, so maybe I shouldn't advertise things because I'm not one of the organizers, but in my personal opinion, not in the opinion of FS Cons, there is a very nice electronics store which is sort of very near Järntorget, a small store called Tema Elektronik, which is usually cheaper than Alpha. You can buy stuff over the counter.
Yeah. And I would say there are the rest of the parts I got from Alpha. And the main reason for that, because I did this partly as an education for work, and they have a contract with Alpha, so it was much easier to get it from Alpha than from Lavicell. And the Lavicell is a very good web shop, but they hadn't been buying from them before, so it's hard for the people actually doing it, they had to, yeah, much more problem for them. But Alpha didn't have most of the hardware I wanted. I didn't have the engines, I didn't have the wheels, I didn't have anything of that part, so I got them to buy stuff from there. And like I said, I didn't have the parts as such, I had to combine it. And then also much of the standard electronic things I could steal from work.
Borrow, you mean?
Oh, well, actually, it was work dedication, so it was okay to take everything they had over. So that is the plastic part here, I found in the drawer. And this one was the biggest capacitor they have lying around, so I took that one. And there's smaller capacitors as well, they had them lying around, the LED I had lying around. So much of that we got that way. But all you need is on the webpage there somewhere. Try to make it understandable.
Any more questions? Oh, well, that's
What is the next step after you?
Oh, the next step.
What is the end? Do you have an end vision or a vision for it?
Yeah, why I did learn this, yeah. I want to make this one into a lawnmower.
Into a
Lawnmower.
I see.
I have this old hand driven.
Yeah.
I was thinking if you put a big engine on that one, it would be, and then 2 wheels with added engines. Then actually I was thinking of that, but add idea on the Golf Icon thinking, and I got a better idea. Because, well, still the lawnmower, but if you take this rotating thing and you make it into a cylindrical fan, you could make an Hoover version of a lawnmower. That'd be cool. I'm not sure it'd be practical, but it'd be cool.
That Arduino board, is that the smallest one?
No, it's a standard Uno one.
Okay.
They are much smaller. And actually when you go to the smaller Arduino boards it gets more complicated. Because the smaller ones you have, the smallest one is a 3 volt system without power in, so that's much more complicated. You have to solder everything in place, and there are no protections on the input and output things. So the smallest one is for professionals who know what they're doing, and then you have this one that is for people who don't know what they're doing. And then you have even a bigger one now. They are giving out the one with the ARM processor in it as well, much more power in it. I think they have released it this week. So there's a lot of levels for the Arduino as well. And the alternative from the beginning, it was a Raspberry Pi, I think. And it may be that when I'm making a bigger robot, I have a Raspberry Pi for the intelligence part, and this one for controlling engines and stuff like that. I think there would probably be something like that.
Why? I mean,
Because figuring out how big the lawn is and not running over brushes and neighbor and things, it needs some better sensors, some more intelligence, and I think I soon will run out with the power of the Arduino. There might be one way to actually keep the Arduino as a driving engine, and it's so they are someone doing a Kickstarter for a little camera with image recognition in it that actually sends what it sees over a serial bus of some kind. And that way I still can use this one, because if I start to need image recognition in the Arduino, I think it will be killed quite quick.
yeah. But so the purpose of using Raspberry Pi and the Arduino would be due to the voltage levels and stuff like that?
The purpose of using the Raspberry Pi would be that I didn't think I could anyway get a web camera with image recognition into Arduino CPU power.
But like, okay, if I ask it this way, why not just the Raspberry Pi and skip the Arduino entirely?
Because the electronics surrounding a Raspberry Pi for doing this kind of stuff is much more complicated.
Yeah.
You need to communicate out with the Raspberry Pi, probably using an SPI bridge, and you need or a nice 2-square bridge, and you need to make controlling stuff that actually is listening to that I2C or SPI bus, and then you have almost made yourself an Arduino before you get there. We need something like the chip from the Arduino to actually decode all that. I think if you are going to make it this little bit simple, you need something like that.
Right, let's. And that was the closing of the final session of this track. What remains in the official program for today is lightning talks at, I guess, 6:15 in the main hall. And then you're free to stay here and socialize and help us eat all the food that's left and finish the beer. We close the venue at sort of 11ish.
Great.
Hope to see you next year.